Computer Science 460, Introduction to Project Management. The content in Sommerville is changed from edition to edition for this chapter, which is chapter 23. We're going to be focused on plan-driven development, project scheduling, and agile planning. The current 10th edition includes information about COCOMO and algorithmic cost modeling in the discussion, but we're going to save that for later in the year. You can still listen to the Beach Boys song COCOMO early if you want. We will cover that as well. So we can start in with a description of software project management, and Sommerville provides a brief treatment of what this entails and partitions it into several activities: proposal writing, project planning and scheduling, project cost monitoring and reviews, personnel selection and evaluation, report writing, and presentation. And not all of these activities are unique to project management, and not all have to be included in the software project management flowchart or operations for the project. Some can go into the general line operations of the organization. And it's really a whole course in and of itself. You'll need enough knowledge to be dangerous here, and Sommerville says that the best programmers don't necessarily make the best software managers. So, basically, how well do programming skills match against project management activities that were on the preceding slide? It's interesting to note that IBM agrees with them. Technical experts at IBM are often paid more than their managerial counterparts because they have different lines for each one. So let's start with the plan-driven project management approach. And basically, plan-driven development is an approach to software engineering where the development process is planned in detail. Development is based on engineering project management techniques and is the traditional way of managing large software development projects. Project plan is created that records the work to be done, who will do it, development schedule, and the work products. Managers use the plan to support project decision making and as a way of measuring progress. There are several arguments in favor of this. Early planning allows organizational issues, availability of staff, other projects to be closely taken into account, and potential problems and dependencies are discovered before the project starts, rather than once the project is underway. The argument against plan-driven development is that many early decisions have to be revised because of changes to the environment in which the software is developed or used, or changing client requirements. So project planning is a pretty time-consuming activity, and it also needs to be continuous. It involves breaking down the work into parts and assigning these to project team members, anticipating problems that might arise, and preparing tentative solutions. The project plan, which is created at the start of the project, is used to communicate how the work will be done to the project team and the customers, and to help assess progress on the project. At IBM, we would have these weekly meetings where we need to do nothing. We would do nothing but review the tasks in the Gantt Chart and assign percentages complete to these values. I don't think this approach went well and made for some really boring meetings. At Ford, my manager by the name of Dean Weingast had a Gantt chart that took up an entire wall. He would walk by the chart, look at the completion date, and mutter profanities every day. I thought he had a better way of doing it than IBM. So, different stages for planning. The first is the proposal stage, and this happens when bidding for a contract to provide a software system. Here you want to provide information that will be used in setting a price and determining the effort necessary to make the software. At the startup phase, plan who will work on the project, how to break it down into increments, and then how resources will be allocated, as well as monitoring mechanisms. Throughout the course of the project, you'll still engage in planning, and basically that's updating the schedules and estimates a la IBM, or just cursing at them the way that Ford did. And it's interesting to note that even in agile development, the startup plan is still needed, basically to allow you to allocate resources to the project. So, different types of plans, and there are quite a few. One is a quality plan that describes quality procedures and standards that will be used in the project. We'll get to those when we discuss quality in ISO 9000. Validation plan, basically how you're going to test the system to show that it conforms to requirements and that it doesn't have any major defects or flaws in it. Configuration management plan, determine how you're going to do configuration management after the system's in place, as well as the maintenance plan that'll talk about requirements, costs, and effort necessary to maintain the system, and then staff development plan, how you're going to get the skills and experience and expertise for the project team members in order to execute the project. And there are other types of plans that you should look into putting together. While things don't always go according to plan, you at least want to have one so you know where you need to devote your time and resources. So this was the planning process from an earlier edition of Sommerville. I'd leave it in here for your enjoyment. I think Sommerville was being intentionally humorous here, but I can never really be sure. This one's written as pseudocode. So in general, what you want to do is determine the resources available. People, equipment, space are the primary drivers. And then probably as well as time, determining partitioning of the work, for example, a work breakdown structure, and assignment of tasks. And then determine the dependencies between these units of work. Which one has to be done first, which one has to be done second, which ones will you put into the current sprint, and then create a schedule. You may not have been exposed to the term work breakdown structure before, but it incorporates the same ideas as stepwise refinement and top-down design that we talked about in CS 150 and 151. So for resources, and this is a little exercise that you can do, create a list of resources for your project. What types of people are you going to need? What type of physical materials are you going to need? Type of workspace you'll need to operate in, and are there any specialized books, software, or hardware that you're going to need in order to complete the project? All these work well for a work breakdown structure, and depending on the amount of time for the class, you may be able to get divide things up reasonably. Sorry about that. So let's talk about work breakdown structures. A work breakdown structure breaks the project down into manageable units of work, that is, atomic tasks. It's the same process as top-down design, stepwise refinement that we teach you in the first two programming courses. So you should be familiar with the concept. You can also break work down according to products, where you select all the products or deliverables that will be included in a final product or a sprint, and break those down into logical tasks. In short, either one of them will work, and often you have a mixture of the two. For example, you can have milestones, which are recognizable endpoints in the activity, and deliverables, which are actual products. For example, your proposal. Agile methods have slightly different ways of dividing the work. So, as another exercise, create a work breakdown structure for your project. Partition it into atomic, self-contained units of work. Sommerville specifies 1 week time units, but yours can be smaller or larger. It can be 2 to 3 hour, time units, whatever you feel is a atomic unit of work. What you can reasonably accomplish as a task. And the important thing is that these should be logical partitionings. Also identify major events over the course of the project. These are milestones, and you can find those on the front page of Lalima under the announcements. The next thing you'll want to do is construct Gantt and PERT charts. So a Gantt chart is the same thing as Sommerville's bar chart, which is pictured here and is also on page figure 23.6 on page 665 of the 10th edition. Basically, it's a graphical notation that displays the activities on a timeline and shows who is responsible for it. It was invented by Charles Gantt in 1917, so it's been around for quite a while. Here you can see the project starts at week 1 and finishes at week 12. You can see the different activities denoted as T1 through T12 and when they take place. For example, you can see T1, T2 overlap, but we're not going to begin T5 until we have T2 complete. T3 seems to be dependent on T1. The other way of representing these is through something called the Program Evaluation and Review Technique, or the PERT chart, or the CPM, which is Critical Path Method. The PERT chart is the same as the activity network diagram, which looks like a directed graph. And I believe this was invented by Booz Allen Hamilton. And this is a depiction of a PERT chart from Wikipedia. Here you can see the activities that are on the critical path in red. So define the dependencies between your work units in your work, determine the timing for the individual work, and then draw a network diagram and label it according to the PERT chart methodology. We'll cover a bit of that during the class time. You can also do this with project scheduling software. Microsoft Project is the one that we frequently use for this class. It's available from DreamSpark or Microsoft Academic Alliance. Primavera is probably the best one out there, but it costs major dollars. It's now owned by Oracle, so it means it costs even more dollars. I should probably put a fourth one in there. Plandora, I just like the name of that one. SAP Business by Design, software as a service. SAP, better return on investment. Not sure, I haven't used this one. Trello is designed to support Agile and Kanban, which we'll talk about in a bit later in this presentation. It ties to smartphones. Clarizon is another one like SAP that's software as a service. Project Libre is open source, and it's listed as one of the top open source products. And Agile Font, which, as the name implies, is based on Agile Methods. However, this open source project management tool also supports product portfolios, project sprints, and multi-team development. You can see their full feature set in the Agile Font user guide. Offers free and open source product that can be downloaded and deployed in your own private cloud. They also have a paid service. Basically, there's a ton of these that are available, and you can look them up by doing a simple Google search. Project planning or project scheduling software. Wired also has a coverage of these, and again, you're free to use any of them. But we do still have MS Project as part of the Academic Alliance. So, review of terms for these. PERT and CPM charts are network diagrams of the activities in a project. A Gantt chart is a bar chart of the activities in a project. Gantt charts are useful for showing timelines, but sometimes difficult to see dependencies between tasks. A precedence relationship indicates that one task will take place before another in a project. Critical path, this is the series of activities that take the longest time to complete. And basically this has no slack. So a delay of a critical path activity will result in a delay of the entire project. Early start and early finish is the earliest time that a project activity can start and finish, while late start, late finish is the latest time that it can start and finish, and those will be the same for ones that are on the critical path. Other terms, overhead tasks, these are ones that have to be done every day but don't add anything to the completion of the project. For example, you may have daily staff meetings or have to fill out timesheets or check email or log into certain systems to update things. Those are overhead tasks. Effort time is the amount of time you'll have to put into the project versus elapsed time, which is the amount of time that is actually passed. And these two are not always equal. You may have 2 hours worth of effort time, but you watch some cat videos and it turns into 3 hours of elapsed time. Resource allocation is the careful allocation of resources. Slack or float is the amount of time that a project can be delayed before it becomes on the critical path. You should be familiar with that. Basically, how long can you delay an assignment before it becomes the most critical thing you have to do? Resource leveling is basically when you fix resources that are over allocated by assigning more tasks to a resource that has available working time. Generally, resources are leveled in two ways. By delaying the amount of time between the scheduled start of the task and time when the work should actually begin on the task is changed due to resource availability, and then splitting. So a task whose schedule is interrupted. For example, a 2-day task that doesn't require contiguous work can be split. So the first day of work is scheduled for Monday and the second is scheduled for Thursday. So that's splitting versus delaying in terms of resource leveling. Agile planning is a bit different, and it's relying on customer involvement and availability. It can be difficult to arrange as customer representatives sometimes have to prioritize other work and are not available necessarily for planning. Some customers may be more familiar with traditional project plans and may find it difficult to engage in an agile planning process. Agile planning works well with small, stable development teams that can get together and discuss stories to be implemented. However, when teams are large and geographically dispersed, or when team membership changes frequently, it's practically impossible for everyone to be involved in the collaborative planning that's essential for Agile project management. So, Agile Methods of software development, these are iterative approaches where the software is developed and delivered to customers in increments. Unlike plan-driven approaches, the functionality of these increments is not planned in advance, but is decided during development. Decision on what to include in an increment depends on progress and on the customer's priorities. Customers' priorities and requirements change, so it makes sense to have a flexible plan that can accommodate these changes. Release planning is you look ahead for several months, decide on what features should be included in the release of a system. Iteration planning is shorter, basically focus on the next planning increment of a system, and these are typically 2 to 4 weeks of work for the team, or equivalent of a sprint cycle in Scrum. In XP, this is covered to some extent in Beck's article. The team and customer identify stories. The team estimates the time to develop the story by story points, calculate the velocity, these are effort points implemented by the team per day, and then select the stories for a release and the order in which you'll do them. Again, this works well if you have an involved customer. And for XP, Extreme Programming, Iteration Planning, the developers break down the stories into development tasks that take 4 to 16 hours. They then sign up for the tasks they will implement and review the progress halfway. And should be an experienced team. The other thing is no one is going to grab the cruddy task, and it can't be assigned to anyone by the project manager, at least in theory. So that's one of the things you have to account for. So really breaking these down into equal atomic tasks is important. Anyway, you have to estimate completion time and number of hours. You're just doing it without the aid of the scientific tools and mathematical tools such as Gantt and PERT charts that have been developed. Kanban boards. These originated at Toyota for just-in-time production. The idea was that factory workers could take their choice of task off the board, complete that task for the day, and then put it back in the completed task board. So, what can go wrong with this? This looks like an organization, development professionals starting managing projects. Serious question for this relates to how developing software is different from assembly line operations. And there are some major differences here. It can be fun at first, but teams seem to lose interest in it and the board gradually disintegrates. Also, not all tasks are atomic or properly broken down, so people have a tendency to grab the easier ones. So the vision of the Kanban board is this. People are, have a nicely managed board, and they're taking tasks, and it's an equal distribution of tasks. The reality looks somewhat like this. Another Agile tool that you may see is the Burndown Chart, and it sounds a lot cooler than Program Evaluation and Review Technique or Gantt Chart. Basically, this type of chart will show the current progress against the backlog in terms of the number of story points. And you can use things other than story points, such as hours or effort time that's required, but a lot of these use story points. And story points are numbers that tell the team about the difficulty of the story. Story points are arbitrary, but they should be related to the complexities, risk, and effort involved. Traditional project planning will use hours. Some Agile groups recommend using the Fibonacci numbers to classify story points. It's really up to you. If story points are bigger than reasonable, for example, 21 story points versus, everything else is 1, 2, then you need to break that story down into smaller stories so that it's manageable. When you get done, this is what a hand-drawn Burndown chart will look like, and you can see the dates on the bottom, and you can see the effort on the y-axis. So progress on a Scrum project can be tracked by means of release Burndown chart. Scrum Master should update the release Burndown chart at the end of each sprint. The horizontal axis of the sprint Burndown chart shows the sprints. The vertical axis shows the amount of work remaining at the start of each sprint. Work remaining can be shown in whatever unit the team prefers. Story points, ideal days, team days, hours, etc. And last but not least is the Nico calendar. It basically shows your team members' moods so that you can monitor progress. Here's my little Nico chart for you. During times where we're teaching the software engineering class, it's one thing, and on weekends it's another. And that's the end of project management. Thank